Created by MindSticks Foundation Trust. Hello, my dear students, and a very warm welcome to today's session. I am your teacher for today, and I am absolutely thrilled to guide you through a really fascinating journey into the world of coordinate geometry. Come, let's learn together.
All right, let's look at our roadmap for today. First, the section formula. Second, the midpoint shortcut. Third, finding the centroid. Fourth, a summary of formulas. And fifth, solving practice examples. So moving to our first topic, 1. The section formula, finding the exact point. Imagine you've got a straight line segment, right? And you want to place a point on it, but not just anywhere. You want it to divide the line into a very specific ratio, say m to n. Now, how do we find the exact mathematical coordinates of that precise point? Well, observe the figure closely. We have our segment AB, and point P is sitting right there. To figure out exactly where P is, we just drop perpendicular lines straight down from points A, P, and B right onto the x-axis. Notice how that gives us 3 parallel lines? That right there is the secret to unlocking our formula. Let's see how this builds up step by step. Step 1, as we just saw, is drawing those perpendiculars. Step 2 uses a really brilliant geometric property, the property of intercepts of 3 parallel lines. You see, the ratio of the segments on our main line, m divided by n, is exactly equal to the ratio of their intercepts on the x-axis. So by setting up a simple equation using those x-intercepts, we can just cross-multiply. Step 3? That's just basic algebra, my friends, and it beautifully hands us our final x-coordinate. And you know what's really beautiful about mathematics? This symmetry. The derivation for the y-coordinate perfectly mirrors what we just did for the x-coordinate. Just imagine dropping those same perpendiculars, but this time to the y-axis. The logic is identical. So our complete section formula gives us the x-coordinate as m times x2 plus n times x1, all divided by m plus n. And for the y-coordinate, exactly the same structure. Just swap out the x's for y's. Simple, isn't it? Having established that solid foundation, let us move to our second topic. 2. The midpoint shortcut, a special case. Before I show you the math for this, I want you to think about this for a second. What happens if point P divides the line segment exactly in half? If it sits perfectly right in the middle, then the left side is equal to the right side, correct? This means our ratio, m to n, becomes exactly equal. Basically, m is equal to n. So let's see how this simplifies our lives. If we take our slightly complex section formula, and everywhere we see an m, we just substitute it with an m because they are equal now, right? Something magical happens. The m's beautifully factor out and just cancel each other from the top and the bottom, and we are left with this elegant, highly simplified equation. X is simply x1 plus x2 divided by 2, and y is y1 plus y2 divided by 2. This, students, is the midpoint formula. It's a really handy, time-saving special case of the section formula. Let's keep this great momentum going. Topic 3, finding the centroid, expanding to 2D shapes. Now we are scaling up from a single line segment to a two-dimensional shape, the triangle. Take a look at the shape on screen. We have triangle ABC. Now, a median is simply a line drawn from a vertex, like A, straight to the exact midpoint of the opposite side, which is D. The point where all 3 medians of a triangle intersect, that is our point of concurrence, called the centroid, labeled G here. Now try to recall a fundamental property from your earlier geometry classes. The centroid always divides the median of a triangle in a strict 2-to-1 ratio. Observe how beautifully everything we have learned so far just comes together here. Step 1, we find point D. Since D is a midpoint, we use our shiny new midpoint shortcut. Step 2, we look at the segment AD. We already know G divides it in a 2-to-1 ratio. So what formula do we use? That's right, the section formula with m equals 2 and n equals 1. Finally, step 3. When we plug the midpoint coordinates of D into the section formula for G, everything simplifies down to a wonderful conclusion. The x-coordinate is simply x1 plus x2 plus x3 divided by 3. It's basically a perfect average of the 3 corners. We have definitely covered a lot of profound mathematical ground today. Let's take a quick pause with topic 4, summary of formulas, your coordinate cheat sheet. Please take a good look at this Remember This box. This is your essential cheat sheet. First, we have the section formula. That's for any general ratio m to n. Second, the midpoint formula, for exactly cutting a line in half. Notice we are dividing by 2. And third, the centroid formula,
for finding the center of mass of a triangle, where we divide by 3. I highly recommend you jot these 3 down in your notebooks right now. They are literally the keys to unlocking coordinate geometry.
But of course, formulas are only really useful if we know how to apply them, isn't it? So, moving to topic 5, solving practice examples, applying the logic. It is time to prove these formulas actually work by tackling some textbook problems together. Let's look at solved example 1. We have point A at -7, 4, and point B at -6, -5. Our goal is to find the exact coordinates of point T, which divides the segment in a specific ratio of 7 to 2. Now, before rushing into calculations, it is always best to follow a structured approach. Step 1. Clearly identify your x1, y1, and x2, y2. Here, A is your first point, B is your second. Your m is 7, and your n is 2. Step 2. Since we have a specific ratio that is not equal, we obviously choose the section formula. Step 3. Simply substitute the values carefully into the formula. That gives us 7 times -6 plus 2 times -7, all divided by 7 plus 2. Solving this gives us -56/9 for the x-coordinate, and similarly, -3 for the y-coordinate. You see, methodical thinking always leads straight to the right answer.
All right, let's step it up and try a slightly more advanced problem. Example 4 asks us to find the points of trisection for a segment joining A and B. Now, please don't let the word trisection confuse you. It simply means dividing the line segment into 3 perfectly equal parts. To do this, we are going to need 2 points on the line. Let's call them P and Q.
Here is where the true logical test lies, so pay close attention. Look at point P. There is 1 equal part to its left and 2 equal parts to its right. Therefore, point P divides the segment in a 1 to 2 ratio. Now look at point Q. There are 2 parts to its left and only 1 to its right. So point Q divides the segment in a 2 to 1 ratio. From here, we simply apply the section formula twice, once with m equal to 1 and n equal to 2 for point P, and then again with m equal to 2 and n equal to 1 for point Q. It is exactly the same logic, just applied in 2 different ways. Brilliant, isn't it? We have done some really excellent work today, but before we wrap up, I want to leave you with a real-world application to ponder over. Imagine you were an architect, right? And you were designing a heavy, triangular roof for a building. How would finding the exact centroid using our formula help you place the main supporting pillar to perfectly balance all that weight? Think about it. Mathematics isn't just numbers on a chalkboard. It literally builds the world around us. Thank you so much for being such attentive learners today. Keep practicing those problems, and I will see you in our next lesson.